Greetings to everyone who is going to view this presentation of arts. We, the students of Keli Technological University, are here with the course project of engineering exploration, titled as Cleaning Meat. I'm Yash Vajandar, and the rest of my teammates are Bharat Shiruguppi, Aditya Yaipai, Shivani Swati. We are under the guidance of Ms. Unnati Kopikar. What is a problem definition? We are supposed to design a semi-automatic cleaning system which is able to clean the given area. It should be portable, user-friendly. It must be lightweighted and should utilize less time to clean. Machine must not be more than 1.5 feet cross 2.5 feet cross 3 feet in dimensions and must work for 3 hours continuously. The cost of the machine should not exceed Rs 3000. The machine must detect obstacle and store the collected dust and the garbage. This is a function tree. We could mainly identify 4 functions, that is detection, cleaning, user interface and casing. Under detection there are 2 functions, detect obstacle, revert obstacle. Under cleaning there are 3, accept command, collect dust, store dust. Under user interface there are 3, indicating process beginning, indicating process completion, indication of position. Casing, it is the outer covering of a bot, it itself is a function. After seeing the function tree, we then cluster it according to the units. Detect obstacle, revert obstacle is being clustered and put into the recovery from obstacle unit. Accept command, collect dust, store dust is clustered and put into the working unit. Indicating the process beginning, indicating process completion, indication of position is clustered and put into the signal unit. Casing itself is a function. After seeing the function tree and the function clustering, we now move on to the subsystems identified. Mainly, we identified 4 subsystems. Those are working unit, recovery from obstacle unit, signal unit and the casing unit. Keeping in mind the subsystems, we then generated 4 concepts, of which the first one is the edge master. As the name suggests, edge master will be used not only on the edges but also on the normal floors. Here, the cleaning will be facilitated with the use of a circular round brush. The brush will pull in the dust and will store it inside this particular container. The detection of obstacle will be done with the help of IR sensor which will be situated on the head. The motion will be with the use of the wheels. Moving on to the next one, that is the phone controlled bot. In this, both manual as well as vacuuming will take place. Manual cleaning will be with the use of round circular brushes and the vacuuming will be provided with the help of the vacuum box that will be placed inside the machine. This is done so that it facilitates or it makes cleaning more efficient. This particular bot will move with the help of wheels and will be controlled with the use of phone. Next comes the vacuum box. As the name suggests, the whole cleaning will be done with the help of vacuum itself. In this, the dust collected will be stored in this particular area and this particular bot will move with the help of rollers and will be controlled with the help of a remote. Next one is the magical handle. This particular bot is totally manual. It will be there in the user's hand. The cleaning is done with the help of 2 round brushes and 1 cylindrical brush. The handle is being provided so that the user can take it anywhere where there is dust. After seeing those 4 concepts, we found this particular concept to be more feasible as it has vacuuming as well as manual cleaning. Thank you, and the next part will be continued by my other teammates.
Hello everyone, I am Shivani Swati and I'll be presenting to you the virtual implementation of the floor cleaning bot. This is the virtual model of our floor cleaning bot. It can be divided into 2 parts, the casing and the base. The casing is composed of casing unit and the base is composed of 3 units, the vacuuming unit, the cleaning unit and the motion unit. The base and the case are joined together with the help of hinges which makes it easy for the user to open the bot in case of necessary. This is the casing unit. It is about 15 to 20 cm in height. It has got 5 different parts made of acrylic sheet. They are all joined together with the help of L clamps and nuts and bolts. There is a hole in the back portion which lets out the exhaust air from the vacuum section. There are two IR sensors attached in the front portion which detects the obstacle. There is a buzzer attached in the front portion which buzzes when the bot encounters with the obstacle. There is a LED attached on the top portion which indicates the process beginning and termination. This is the base. It has got the dimension of 30 x 20 cm in length and width. It is composed of mainly three units: vacuuming unit, cleaning unit and the motion unit. There is lot of space in it to accommodate the internal circuit. In total, we have used 5 DC motors, out of which 2 to drive the brushes, 2 to drive the wheels and 1 to drive the fan in the vacuum section. The brushes are attached to the front edge of the base, are made up of plastic fiber. The wheels are attached to the bottom portion with the help of motor clamps. The vacuum section is made up of clear plastic. The hose of the vacuum section is made up of acrylic sheet and it extends out of the base so as to collect the dust efficiently. The connecting pipe between the vacuum section and the hose is made up of fiber pipe. The fan used in the vacuum section is a regular toy fan which are available in the market. There is a wire gauze between the fan section and the dust collecting portion so as to collect the entire dust in the middle portion of the vacuum section. The next part is continued by my next teammate.
Hello everyone, I am Bharat and I will explain the flowchart of our entire system. The process begins by reading an input or command from the user like F to move forward, R to move right, L to move left, B to move back and T to terminate. First, it checks for the values of IR sensor. If the value of both the IR sensor are 0 and 0, the condition is true, it performs any one of the following operation. If the entered command does not match any of the given command, it will again ask the user to enter the command. If the value of any one of the IR sensor or both the IR sensor is 1, the condition fails, the system stops, buzzes for 2 seconds indicating that there is an obstacle, moves backward, again checks for the values of IR sensors. Therefore, the cycle continues. This is the circuit diagram of our entire system. We are using an Arduino Mega 2560 to control the bot. 4 DC motors, 2 DC motor to drive the brushes which will rotate in opposite direction. 2 DC motor to drive the wheel which will rotate in same direction, 2 IR sensor for the detection of obstacle, an LED to indicate the beginning or ending of a process, a buzzer which buzzes when an obstacle is detected, 3 2-channel relays to control the motors. A toy DC motor is attached to the fan for the creation of vacuum suction. A battery of 12 volt 3 ampere hour is used. Bill of materials. The materials we purchase for the construction of our bot are 4 DC motors of 30 RPM, 2 IR sensor, 2 wheels, Arduino, battery, LED, buzzer, 2 brushes, vacuum container, a vacuum hose. The materials that were available off-shelf were bolts, nuts, washers, motor clamp, nylon rod, hinges, acrylic sheet used for the base and foam sheet used for the casing purpose. Motor sizing and battery sizing. Motor sizing. To calculate the speed of the motor, we first calculate the torque, and the torque has to be divided by the total number of DC motors because the torque gets equally divided among them. Hence, the speed of the motor depends on the total weight of the model, radius of the wheel used, and the number of DC motors used. By calculating all these, we obtain the speed of the motor as 30 RPM. Battery sizing. The battery sizing depends on total number of DC motors used, current consumed by each motor, and the working time of the bot. By calculating all these, we obtain the specification of the battery as 12 volt 3 ampere hour. functional specification of the entire system. Notification of power on and off. We are using an LED for the indication of beginning a process and ending a process. When the LED remains on throughout the process and will be off when the process gets terminated. Clean a given space. The bot has to move around and clean a given space. Therefore, the dimensions of the wheels are these. Sending the command. The bot receives a command through means of a device. Collection of dust is done with the help of brushes. Therefore, these are the specification of the brushes. Storing of dust is done in the vacuum section. Hence, these are the specifications of the vacuum section. Power efficiency. We are using a battery of 12 volt and 3 ampere hour. Obstacle detection is done with the help of IR sensor. These are the specification of IR sensor, and when an obstacle is detected, the buzzer will buzz for 2 seconds. The next part will be continued by my teammate.
Hello everyone, this is Aditya Pai presenting to you the simulation of the circuit. We are using a total of 5 motors in this circuit. These 2 are the brushes, these 2 are the wheels, and this is the fan of the vacuum. We are making sure that the 2 brushes move in opposite direction for the cleaning efficiency. This is the left wheel and this is the right wheel. We are using a LED to indicate the beginning as well as the end of the process. We are making sure that the LED is on throughout the process, indicating that the system is on. We are using slide switches to represent the IR sensors. We are also using a buzzer which buzzes whenever an obstacle is detected. When I give the command F, it means that the system should now move forward. As we can see, all the motors have started as well as the LED is on. When I give the command R, it means that the system should now turn right. That is, the right wheel stops and the left wheel continues. When I give the command L, it means that the system should now turn left. That is, the left wheel stops and the right wheel continues. When I give the command B, it means that the system should now move back. We can also observe that the LED is on throughout the process. Now, if I switch on either of the 2 slide switches, it indicates that an obstacle is detected. Under such cases, the buzzer buzzes and the system stops. The system moves back for a while and then again stops. This process continues until the respective slide switch gains back its original value. We can now give the next command. If I give the command T, it means that the system should stop. We can observe that all the motors have stopped and the LED blinks for a while and then stops. If we want to find the location or the position of the system, we can give the command T. By doing so, the LED blinks for a while indicating its position.
At the end, we would like to share our views regarding this course. Being an engineering student, it is really necessary for us to know about how a system is developed. This course provided us a great opportunity to explore all the possible ways in which a system could be developed. We were able to learn a lot of things such as engineering design process, multidisciplinary skills for problem solving, and most important, the engineering ethics. We also learned how to work in a team and face the problems as a team. Also, we could explore various platforms like GitHub and Thinkercad, which helped us in building our course project. On behalf of my whole team, I would like to thank Unnati ma'am for always being there for us during the whole course project. She has never left our side and has worked hand in hand with us. We are Really very grateful to have a mentor like her. Thank you, ma'am. Lastly, we would like to thank Keli Technological University for providing this course for us. We really had a great time exploring concepts and ideas. Once again, thank you one and all.